This is probability question coming from the year 2023, GCE Paper 2, question number 3B. Please, let's see how we answer such kind of questions under probability. So the question reads, a girl has 7 green apples and 6 red apples in a bag. She picks one apple at random from the bag and eats it. She picks another apple and eats it. So always try to analyze the information that has been given to you. Analyze the information that has been provided for you. Okay, very important. So in a nutshell, we have got 13 apples altogether. We have got 7 green apples and 6 red apples in a bag. Take note. So altogether they make it 7 plus 6, that is 13. Very important. Another point that is worth note is the latter part of this statement here, which says she picks one apple at random from the bag and eats it. So she picks one apple in this bag without considering the type or the color of the apple. Okay, very important. So she picks one apple from the bag without actually considering the color of the apple. That's what it means at random. Take note. Okay? Then once she did that, she went on and ate that particular apple. Yes, she eats that apple. So the statement eats, it simply indicates that this type of probability, it is without replacement. The moment this person picks an apple from the bag, that apple was not returned. Okay, very important. She further picks another apple and eats that apple. Okay, so 2 attempts consecutively. So this was the first attempt, one apple that was picked from the bag. Okay, then there was another one, or a second apple that was picked from the bag and it was eaten, meaning it was not replaced in the what? In the bag. That is the type of analysis that I wanted to actually have. Now, question number 1 says, draw a tree diagram to illustrate all the possible outcomes. Draw a tree diagram to illustrate all the possible outcomes. So what you do here is to come up with a tree diagram. The tree diagram is very simple. You come up with a tree diagram here, and this will be our tree diagram. Now, we are told we have the green apples and the red apples. Okay? Now, the green apples originally were 7. So we're going to write in the first branch here, we'll write 7 out of 13. The red apples were 6 out of 13. Now, the statement here reads that this girl picks one apple at random from the bag and eats it. So meaning that indicates, the first attempt. So this was done, this was the first apple that was actually eaten there. So now, suppose in the first attempt, in the second attempt here, okay? In the second attempt here, suppose that from this particular bag that we're seeing here, observe, from this particular bag that we're seeing here, originally we had 7 green apples and 6 red apples. Take note. Now, suppose one apple is picked, okay, is picked from the bag and eaten. Take note. Now, suppose if we go by this branch here, we are saying, suppose that apple, it was a green apple. Suppose that apple is a green apple. What happens if it's a green apple? So I'm going to come up with another branch here, indicating the green and the red. Again, we come up with another, branch here, having the green and the red apple. Observe carefully here, please, so that you get to understand how we answer this question. So why have we come up with the two, attempts? So this arrangement, the first arrangement here is referred to as the first attempt, and the second arrangement here is referred to as the second attempt. Now, how do you tell to say you should arrange the tree diagram this way? We should have the first one here, the original one, and the second one. How do we know? It's about the question that says, you ask yourself to say, how many times were apples picked from the same bag? It was twice. It is twice in the sense that the first apple was picked from the bag at random and it was eaten. And another apple, she picked another apple. So this indicates that you have got two attempts. The first attempt, it is the original arrangement. The second one was the one where she had to pick and eat those apples. And those apples were not returned in the bag. Okay, that's how you tell. So that one is dependent upon the number of times this young girl picked apples from the bag. It depended upon the number of times. In this case, she picked those apples twice. The first time and the second time. No wonder we have got the first arrangement and the second arrangement. Please take note. Thank you. Now let's see and try to understand this particular question. So the first one, suppose the apple that was picked at first, it was a green one. If it was a green one, then the green apple, actually, it was not replaced because it was eaten. Meaning from 7, they became 6. Meaning the total also changed in the bag. Okay, from 13 to 12. You see? That's what you do. Now remember, this is done one at a time. At first, suppose she picked a green, apple. Okay, then the green apple from 7 they became 6. Out of the total also changed from 13 to 12. Meaning the red apple here maintained. Because the red apple here were not tempered in this particular case. We are supposing that the first apple that was picked was a green one of the 6 here from 7. Meaning the red apple maintained, there was still 6 here. 6 out of the total also changed because it is the same bag we are talking about here. Okay, this is what you do. Then you move on to the red one. In the second case, suppose it was a red apple that was actually picked. If it was a red apple, then what happens here? So what happens if it was a red apple that was picked? The green apple maintained. Okay, there were 7. Okay, so you write 7 here. But the fact that you picked one apple which is a red one, the number still reduced from 13 to 12. So you write the number 12 here. Okay, that's what you do. So 7 out of 12, 7 out of 12. Meaning, since you are saying it's a red one, it's a red apple, meaning the red apple they reduced from 6 to 5. They reduced it by 1, so this they became 5 out of what? Out of 12 here once again. That's the idea. Once you do this here, you will have actually drawn the tree diagram. Now, let's try to illustrate. Let's try to put in all the possible outcomes. Let's see how we do that. So, for example, the first branch here, we'll say GG, the probability, observe, probability P, G, G. Okay, we need to know GG there. And the second probability, or the second possible outcome, probability of G, R. This is what you do always. Then move on to the other branch, which is RG. So this is the probability of R and the G. Okay? We're going to write the probability here. Then of course we move on to the probability of what? The probability of the last one, which is R. Let's see how. Then let's try to compute the probabilities out here. So GG simply means 7 out of 13 times 6 out of 12. So this will be 7 out of 13 times 6 out of 12. Then let's try to simplify this. So you see here that 6 out of 12 is the same as half. Take note. Okay? Since this is half here, we're going to have half here because that is 6 out of 12. Then when you simplify this will be 7 by 2, 7 by 1 rather, that will be 7. 13 times 2, that will be 26. And we cannot simplify it, therefore this is the possible outcome. The second one is this one here. It is 7 out of 13. The second one, it is 7 out of what? 13. Okay, times the same 1 over 2 because that is 6 out of 2. 6 out of 12 rather. Okay, so we see that the second one equally will be the same. The second one will be 7 out of 26. The third one, this will be 6 out of 13 and 7 out of 12. So see that here, 7 out of 13 here times 6 out of 12. Is it? I mean times, okay, this is 6, okay, out of 13, okay, times 7 out of 12, observe. So if you have to divide it diagonally, we see that 6 into 6 is 1, 6 into 12 is a 2, 7 by 1 is a 7, so 13 times 2, that's 26. So this is just the same here. Then let's go to the last one, which is RR. So that will be 6 out of 13. So you are saying 6 out of 13. Okay, so 6 out of 13 times 5 out of 12. Observe. Diagonally, we're going to have half. Okay. Then you can multiply 1 times 5, that is 5. Okay. Out of 13 times 2, that's 26. So 5 out of 26. Very good. Just write 2. Okay. This is what we have there. Alright, now after illustrating like this, you'll have answered question number A. Question number 3B1. You'll have answered this particular question. And this is the solution to question number 1. Okay? This is what you do. Now let's move on to question number 2. We'll use the other side there. Question number 2. Let's see how we answer the question. So question number 2, it says we want to find the probability that the first apple eaten was green. So I want to find the probability that the first apple eaten, the first apple that was eaten was actually a green. Probability that the first apple, it was a green one. How do you write this one? Very simple. Very simple. So if this is the case there, then we know the arrangement will be the probability of green, or it should be the probability of green, red. This is the arrangement. Very important. Why are we writing this? Because the statement says the first apple that was eaten was a green one. So it is either GG or GR. The idea is to start with green apple. That's the idea. Okay? So we see that in GG, we have the first apple eaten as a green apple. In GR, we have the first apple eaten to be a green apple. No wonder you can write GG or GR. Okay, once you do this, you simplify the probabilities. Now we know the probability of GG is already here. We have it here. This is 7 out of 26. So we simply write 7 out of 26 here. 7 out of 26. The word or in mathematics and probability, it simply means that you're going to add the two probabilities. Then the GR, you come here, you check where GR is. We see that GR is the same as GG, and that is to say 7 out of 26. From here, we simplify these two fractions. We express them as a single fraction. We see that the lowest common denominator is 26. Therefore, the numerators will be added, and this will be 7 plus 7. Okay, when you simplify this, you have 14 out of 26. If you simplify further, 2 into 14, that will be 7. 2 into 26, that will be 13. Therefore, 7 out of 13 is the solution. Thank you for watching. Please continue liking my videos and subscribe to them so that each time I upload any video, you're actually able to be notified. See you next time.